So, serverless doesn't mean secure. Lambda function URLs are a good example of how small configuration choices can create real attack path. Hello friend, Morningstar here, and today we'll talk about another important AWS service called Lambda Functions. But more specifically, I want to focus on Lambda URLs and show you in practice how carelessly exposed services can pose serious security risk. But before we continue, if you are new here and interested in AWS security, I have a video about other services like IAM, STS, S3. So hint for this video should appear right now in one of the corners, so feel free to check it out after watching this video. And now, let's dive into Lambda functions. AWS Lambda is a serverless compute service. That means you don't manage servers, operating systems, or scaling. You just upload code and AWS runs it for you in response to some event with a specific set of IAM permissions that allows it to interact with other services. Lambda function can be triggered by many things: an API request, S3 upload, a message from a queue, or a scheduled event. It runs for a short time, executes the code, and then stops. If you need public endpoint to call Lambda function, AWS provides Lambda function URLs. This is a built-in HTTPS endpoint attached to the function. Depending on how it's configured, it can be protected with IAM authentication, or it can be completely public. And when it's public, it becomes a part of application's external attack surface. And that's what we are going to explore today. So, if it's public, can it be enumerated as a black box? Well, not exactly. You see, when you create function URL, Lambda automatically generates unique URL endpoint for you. And function URLs do not natively support custom domains, although they can be placed behind some service like a CloudFront. So, enumerating them from pure black box perspective is highly unlikely. But there are still cases when you might be able to identify them. First case is environment leaks. During testing, you might find public repository or environment file where the URL is included. Or another case is when Lambda URL is used as backend API for web app. Then you may see the URL directly in requests. If you found them in public through other ways during assessments, feel free to share your experience in the comments. I'd be so interested to read it. But most often you encounter them when you find AWS credentials and gain access to the account, or when you're working in assumed breach type of assessments. So let's see it in practice. So for this video, I'll be using CloudFoxable, an intentionally vulnerable AWS environment. They have a lot of interesting challenges on their CTF platform. I'll leave a link in pinned comment if you want to try them out. And if you'd like to see videos on other challenges, let me know in the comments. And for today, we'll focus specifically on Lambda function URLs using FURLs1 and FURLs2 challenges as examples. Starting with the first one, the challenge description says, a Lambda function URL can be used to expose a Lambda function to the internet without an API gateway or another load balancer. This is really handy for builders, but can also be really handy for offensive security folk as it's ripe for misconfiguration. And in this scenario, I'm working with read-only AWS credentials. First, I'll list all Lambda functions in account with command AWS, our profile, in this case CloudFoxable, Lambda, list functions. On the screen, we can see several functions. It would be beneficial to go through each function to get details, but to save some time, let's go straight to the function with challenge name FURLs1. Here we have some information on this function, but we can get more details with command AWS, our profile, Lambda, get function configuration, function name, and the name of our function. Here we have more details about this function, but nothing immediately stands out here. So next logical step would be check whether this function has function URL attached. So for this, we'll use command AWS profile, our profile name, lambda list function URL configs, function name, and name of our function. And here it is. We can see a Lambda function URL, and more importantly, the IUth type is set to none. That means no AWS credentials are required to access this endpoint. So you can see that the URL itself is long and not something you could realistically guess or brute force. But now we can simply open this URL in our browser. In this challenge, the response contains flag, which will be blurred not to spoil the fun, but in real production, this could be some internal sensitive data. Also, there is a tool called CloudFox we can use to automate our enumeration. I will put the link for this tool in pinned comment as well. And now let's quickly look at the available options. Here we have option to run enumeration of all services with all checks, and also we can run check for a specific one. For our task, we will need Lambda and endpoints options. To collect the same data about Lambda functions, we will use command CloudFox AWS Lambda -p for our profile CloudFoxable, and I will use outdir option to put results in current folder. And now we need some time to perform enumeration. And now we have a list of existing functions in our account with role attached. And now let's check for endpoints. CloudFox, AWS, endpoints, our profile, and current folder. As you can see, it searched through other services, not only Lambda, and now we can see the same URL for our function. Now let's move to our second challenge called FURLs 2. And if you are paying close attention, you might already have noticed second URL in previous output, but let's approach it more systematically, starting with listing Lambda functions again with command AWS, our profile name, Lambda list functions. And we can see another function called IUFME. And this time, something immediately stands out: environment variables. We can see variables like Lambda HTTP user and Lambda HTTP password. That's already a red flag, but quick note that these variables can also be found with command AWS profile, our profile name, Lambda, get function configuration, function name, and the name of our function, IUFME. Here we have details about this function and also environment variables. And just like before, we can check whether this function has function URL attached. AWS profile our profile name, Lambda, list function URL configs, function name, and the name of our function, ayuv.me. Again, ayuv type none means we don't need AWS user to access this URL. Let's open this URL in browser. And here we can see text to authenticate, send a GET request with following parameters, username and password. Probably we could try to brute force it or use leaked credentials if we have any, but we already have credentials from function environment variables, so we can simply use those. Just put it as a parameters and copy from output of command. Here for username we have admin, and for the password we have not summer 2023. And once again, the challenge returns a flag. In real environment, this could be easily sensitive production data. And finally, let's look at how CloudFox helps here as well. We already have results for Lambda functions and endpoints, and using envars model, CloudFox automatically collects environment variables across services. So the command would be CloudFox AWS env vars, our profile, and our dir for current directory. And here we can see the credentials for ayuv.me function, and now we solved 2 challenges using manual and automatic ways. So to wrap this up, Lambda Function URLs are a small feature, but they can have big impact on security. By themselves, they are not vulnerabilities. The problem starts when they're exposed without proper controls with sensitive data stored. And as we saw in these challenges, you don't need 0 days or complex exploits. Sometimes it's just a chain of small configuration choices that can turn serverless into data leak or entry point. If this kind of practical AWS security content is useful for you, feel free to subscribe. I'll be sharing more videos like this. And if you're interested in other security topics, let me know in the comments what you'd like to see next. So thanks for watching, and I'll see you in the next video.